Okay, so now we're looking at recurrence relations for compound interest investments and reducing balance depreciation. So, first thing we're going to do is we're going to look at this one here at the top about Wayne's investment. So Wayne's investing $7,500 with a bank and he's being paid interest rate of 6% per annum compounding monthly. Okay, and we're going to do VN in terms of N months. We want to write a recurrence relation. So things we're going to need. A recurrence relation for compound interest generally looks like V0 is equal to A, the principal. Vn plus 1 is equal to R times Vn. R is 1 plus little r over N over 100. Let's make that a bit neater. Okay, the little r is the rate. N is compounds per year. So how often do we compound? So we've got to say that capital R, big R, which is the multiplicative rate, is going to be 1 plus 6 over, compounding monthly means 12 over 100. So we go to the calculator for that. 1 plus fraction 6 divided by 12 over 100 gives us 1.005. That will help us fill out our recurrence relation, which is now going to be V0 is equal to our principal sum, $7,600. Vn plus 1 is equal to R, which is what we just worked out, 1.005 times Vn, and N is in months. So if we want to work out how much Wayne's investment is worth after 5 months, okay, we can go to the calculator for that. We're just going to need to go through each 5, or we can put it in our graph mode. So we could do 7600, enter, and then we go to the last answer times 1.005, so 1 month, 2 months, 3 months, 4 months, 5 months, 7791.91 if we go to the nearest cent. So V5 is equal to 7791.91. So $7,791.91. Same result if we go on a table. So if we go to our graph mode and we go up and we're going to put in our table here. So U1, UN minus 1, all the same, times 1.005, starting with 7,600. 0 to 30 seems fine, as long as you keep that number 30 reasonably low so you don't stress your calculator out. Press enter, menu, zoom, fit, and we get this, which looks like a straight line. It's actually not a straight line. If I were to zoom in to a box for you, just to show you, it's actually got a bit of a bend on it. Okay. Doesn't look like much, there is a slight bend on it. Okay. If I'd done it for long enough, so if I go back to my graph and I increase that to say 300 or so, 3,000 even, probably a bit too much. There we go. And I menu, zoom, fit. You can see there's a little bit of a bend on it. So if I have a look at the table, should get the same values there. There it is, down number 5, 77919095. Same sort of deal. So back to this, we'll find. Reducing balance depreciation method is the same idea as compound interest, except instead of increasing, we're decreasing in this case. Okay. So here's a motorcycle, $9,800, annual depreciation of 3.5%, N years, so there's no compounding periods this time. All the same, except in this case, capital R is equal to 1 minus little r over N over 100. So for us, that's going to be capital R is equal to 1 minus 3.5 over 1 over 100, because it's just per years. There's no extra compounding periods. Stick that in our calculator. 1 minus 3.5 over 100 gives us 0.965. So the recurrence relation is the same sort of deal. V0 is still A, Vn plus 1 is still R times Vn, except this time that R is going to be a number less than 1 to make it go down. Depreciation is all about losing value. So V0 is $9,800. Vn plus 1 is equal to 0.965 times Vn. And that gives us our recurrence relation. Generate a sequence of numbers that represent the value of the motorcycle from year to year for 5 years in total. Write the values of the terms correct to the nearest cent. So to save me the effort, I'm going to put that into my calculator. So I'll go to the graph and I'll close that table. Go back to the previous table here and I multiply by 0. This time I'm multiplying 965. That's what I'm going to put there. 0.965. I'm starting at $9,800 and we're going to need to go forward a few steps. So we'll just reduce that to 20 or so, just to not stress the calculator out too much. Windows zoom fit. You can see definitely got that nice bend on it. It's very slow, but it's there. And if I have a look at the table, first 5 years, 9457, 9126.01 when I round, 8806.59, 8498.36, and 8200.92 is how I would do that. So no problems there. What is the value of the motorcycle after 5 years? 8200.92. That's why that mode is handy. You can get some helpful information. 8200.92. Always really important when you use this table to actually click on the cell that you want and check down the bottom for the full value to do the rounding yourself. Don't let the calculator round for you. Now D, what is the depreciation of the motorcycle in the 3rd year? So the depreciation is actually the loss in value. Okay. So if we want to know the depreciation, we need to know V3 and V2, and we need to subtract them from each other. Because the loss of the value in the 3rd year is the difference between how much it was in the 2nd year minus how much it was at the end of the 3rd year. So we know the 2nd year is 9126.01. 9126.01 if we round, minus 8806.59. 8806.59. So we do that on our calculator. So we go 9126.01 minus 8806.59. And it loses $319.42 in that 3rd year. Okay, because that's how much it lost value in that 3rd year.